So this is the Flir Systems stand, and I've got Kevin Ellis here, and I'm going to ask Kevin some interesting questions about thermal imaging cameras.
Yes, well, I mean, thermal cameras we've been manufacturing, or Flir Systems we've been manufacturing since the mid-60s. And the sort of applications that we use them for are general engineering, electromechanical inspection. As we're at an energy show today, that we've got the insulation qualities from housing, from buildings and this type of thing. But you can use them in all sorts of applications, from medical to electromechanical work to clothing to manufacturing, anything that involves heat. I mean, that could be from steel manufacturing right down to very small electronics.
So we've got the a sort of heat map on the screen behind you here.
Yeah.
Could you just tell us a bit more about how you might interpret that heat map from pointing the camera here at Jonathan, our cameraman?
Yeah, we're looking at your cameraman here, and we've got 2 spot meters on, but generally how we work it, we have a temperature scale down the right hand side here, and we tend to use the colder it is, the darker the colour.
Right.
And as we go through a colour palette, the hotter it is. But as you can see, we have 2 measurement functions on here, spot meters. And to the top left-hand corner, you can see spot meter number 2 giving you a temperature.
Yeah.
So remember, with thermal imaging, we're looking at the surface temperature. We can't see through materials, or generally we can't see through any conventional materials. So we're looking at surface temperature in live time and being able to store that information as a standard JPEG or as a video function.
Can you tell us a bit more about how much the cameras cost and the sort of range of cameras that you can get on the market?
Yes, well, from Flir Systems, your entry level is around £900 for a relatively low 60 by 60 focal plane array detector, but ranging through around about 25 to 30 different types of styles of cameras and models up to around about £35,000. So obviously that indicates the kind of expertise that you'd have at the top end. The lower cost ones are straightforward kind of toolbox type units.
What sort of things can the cheaper ones do or can't do that the more expensive ones
can?
Well,
there's a lot of functions in thermal cameras, and you're going to have, with an entry level unit, it's relatively close work, and as the name suggests, a toolbox. It's very close work, kind of the plumber, the simple radiator type application. If you're going through the higher spec systems, the more investment you've got more functions like visual capability, Wi-Fi connections, so you can send information through to an iPad or an iPhone for further analysis by colleagues straight away. You've also got the reporting capability that supports all the cameras. Because generally, if you've got a thermal imaging camera, somebody wants some information from you. So you need a professional capability and a professional software to help you get that information to them, either as a hard copy or as electronically.
If I'm a household, if I give you a scenario, how would I, as a householder, be able to utilize one of these devices to identify drafts in my house or in my business?
Yeah, well, I think if you're going to do that, I would suggest you bring an expert in to do that. If you're going to just buy a camera for yourself, I suggest that you would go through some training course, whether it's a 1-day introduction course to understand what you're looking at. If you don't want to do that, you can buy the service in and they will give you a professional report. You can do it that way. But I would suggest that if you're going to spend a significant amount of finance into a thermal camera, whether it's an individual or a company, that you go on our training courses so you know exactly what you're interpreting and what you're looking at and how you can diagnose what the problems might be.
Has the show been good for you over the last couple of days?
Yeah, it's the first time we've attended it, and I think we'll certainly be doing it next year. I think what we'll be doing is probably fine-tuning it with some different cameras again by next year, perhaps softwares and so forth. So we'll see what happens.
Would you just be able to point the camera at some of the shots around the hall here, just so we can see on the screen?
Well, I'll just pan it around from yourself, around to the other people here. You see, we're in live time. The temperatures are changing, and we can have a look up to the ceiling as well. See the hot beams.
This is the surface temperature you said?
Only surface temperature we can look at, yeah. Yep. There are exceptions to that with certain optics materials and thin film plastics, but in the main it's always surface temperature.
And you're primarily looking for drafts, or are you primarily looking for sources of heat, or both?
Well, both. You can actually negative pressure building. If you're looking at that type of application, it will emphasize a draft as you negative pressure to draw the cold air in, and so the camera can see it very, very quickly. I mean, your cameraman standing there, and we see his feet, but if he was to move, you'd actually see where he's been standing. You see his footprints down there.
That's great.
Yeah. So yeah, it's It's a very interesting industry and product to get involved in.
Thank you very much, Kevin.
You're welcome.